is to find the inverse of the function. F of x is equal to x to the power of 3 minus 5. Let's start with that one first. So this means we have y is equal to x to the power of 3 minus 5. To find the inverse, we can exchange x and y. So everywhere I see y, I'm going to substitute that with x. Everywhere I see x, I can substitute that with y. And then step number 2 would be to solve for y. That's how you can find the inverse. To solve for y, we can isolate the y first. So we can add 5. Here to both sides of the equation. So we get x plus 5 is equal to y cubed. So if I take the cube root of both sides, or raise both sides of the equation to the power of 1/3, then I would isolate the y, and that would be like this. So here we have y is equal to cube root of x plus 5. So we can write this as the inverse, that's the symbol we use for inverse. Inverse of x then would be equal to cube root of x plus 5. If you can follow up to this point, can I see a check mark next to your name, please? Okay, great. Now we need to evaluate composition of f with its inverse. Can you tell me what this should be equal to? Since we know these two are inverse of each other, what would we expect to get here? Yeah, but do you know what is it supposed to be equal to? If you find the composition of f with respect to its inverse, would be always equal to what? Okay, it's supposed to be equal to x. If they're inverse of each other, it's supposed to be equal to x. And let's see if that's true. Otherwise, it won't be inverse of each other. So this means f of inverse of x, that's what it means. So that means we have to evaluate what f of, well, we already evaluated what f of inverse is. In this case, it could be cube root of x plus 5. Now, if I want to find f of cube root of x plus 5, I have to know what f of x is equal to. Well, here is given to us f of x equal to x cubed minus 5. So f of cube root of x plus 5 would be substituting for each x its corresponding value here, which is cube root of x plus 5 in the f function. So if I write this as f of x is equal to x cubed minus 5, then f of cube root of x plus 5 then would be equal to, substituting for each x, cube root of x plus 5, so that would be cubed, that would be minus 5. Let me make sure we can follow this. In this case, again, everywhere I see x, I'm going to substitute this expression here. So if I evaluate this, this would be equal to x plus 5. Then I raise the cube root of something to the power of 3 right here. Then I raise cube root of x plus 5 to the power of 3. This would be equal to the power of 1, right? Because if I have here x plus 5 cube root of that, this is really is x plus 5 to the power of 1/3, right? This would be 1. So if I raise this to the power of 3, it's like I'm raising x plus 5 to the power of 1/3 to the power of 3. As you see, 1/3 times 3 would be equal to just 1, so I end up getting x plus 5 to the power of 1. If you can follow this concept, can I see a check mark next to your name? Okay, good. So over here, you see that f of cube root of x plus 5 would be x plus 5, and then we have this minus 5 here, and if I simplify this, I would get it equal to x as I expected. So composition of any function with respect to its inverse should be always equal to x, and that's what we have. And that's another way to prove if two functions are inverse of each other. If you perform composition of the function with respect to the other function, if it turns out to be equal to x, then we can conclude from there that those two functions are inverse of each other.